Hello students, today we are going to cover the topic relation between Young's modulus, bulk modulus and the Poisson ratio, which is denoted by Y, K and sigma respectively. So, to derive this relation, we will consider a cubical structure A, B, C, D, E, F, G. So we consider a cube A, B, C, D, E, F, G, H of unit volume. How it can be of unit volume? When the edge length of the cube, means length of each side of the cube, L, is of 1 unit. If you multiply length, breadth and height, which will be equal for the cube, you will get 1 into 1 into 1, that is the volume of the cube will be in unit, means 1 unit cube. Now, from all the direction we apply a force means a tension, force per unit area uniformly from all the direction. So we consider that along x axis the tension is Tx, along y axis the tension is Ty, and along the z axis the tension is Tz. So when the tension is applied along the direction x, y and z equally, so individually we will consider first if it is Tx. So due to this tension there will be elongation in the direction of x, means there will be longitudinal strain in the x direction, but as the other two sides are perpendicular to the tension Tx, means the Tz and the Ty, the tension Ty which is along y axis and the tension Tz which is along the z axis, it is perpendicular to Tx. So if in one direction there is longitudinal stress, then there will be other side there will be compression, which we can say that the other side there along Ty and Tz there is a lateral strain. So similarly, if we consider that along the z direction, if the force of tension is produces the longitudinal strain, then along x and y direction there will be lateral strain. Similarly, if in the direction Ty there is longitudinal strain, then the other two direction Tx and Tz there will be lateral strain. So if the longitudinal strain and the lateral strain both it is working on the cube, that will lead to the change in the volume of the cube. So whole along the tension what it is applied leads to the stress, means force per unit area is your stress and the strain. So collectively we will get the bulk modulus, which is volumetric stress by volumetric strain, or we can call it as bulk stress by bulk strain. So, accordingly we will derive the relation between Young's modulus, bulk modulus and the Poisson ratio, which is the ratio of the lateral strain by the longitudinal strain. So, coming, we will write in detail what I have explained. So, already I have written, we will consider a cube of unit length, so that the volume of the cube is in 1 unit. So, we have A, B, C, D, E, F, G, H is a cube of unit volume, and along x, y and z direction the tension, means force per unit area, tensions applied are Tx, Ty and Tz respectively. So, now if we consider the tension along, so now if we consider tension along x direction produces the longitudinal strain, then the other two side means other two directions, that is along y and z, there is a lateral strain. So, if we apply the tension along x, it produces the longitudinal strain in the direction x, and other two direction y and z, there is a lateral strain. So, if we calculate the edge length now along x direction, that will be equal to 1 plus, originally it was 1, as we have considered the edge length to be in 1 unit. So, 1 plus the elongation, which is alpha Tx, and the compression, which under it is beta Ty minus beta Tz. Similarly, if the tension is along y direction, that will lead to the compression along x and z direction. So, if we consider the edge length, which is d along y direction, if we consider dc, then it will be 1 plus alpha Ty minus beta Tz minus beta Tx. And along the z direction, if we consider, then z direction there will be longitudinal strain, and along x and y direction there will be lateral strain. So, if we consider the length of one such edge along z direction, then it will be 1 plus alpha Tz minus beta Tx minus beta Ty. So, we will write it as equation 1, 2 and 3. Now, when we multiply BE, DC and AD, we will get a new volume. So, let us calculate now what will be the new volume. Now, if we calculate the new volume, of the cube when the tension is uniformly applied, it will be equal to BE into DC into AD. We will substitute the value and multiply it, we will get 1 plus alpha Tx minus beta Ty minus beta Tz multiply by 1 plus alpha Ty minus beta Tz minus beta Tx, and again multiply AD, which is 1 plus alpha Tz minus beta Tx minus beta Ty. So, if we multiply the whole and neglect the higher power terms, as alpha and beta are very small number, so we will neglect the higher power terms, we will finally get the new volume. It will be equal to 1 plus alpha minus 2 beta Tx plus Ty plus Tz. We will get the new volume 1 minus alpha minus 2 beta multiplied by Tx plus Ty into Tz. Now, if we consider that the tension along the each directions which we have applied to the cube are equal, means Tx is equal to Ty is equal to Tz is equal to T. We say that it is equal to T, then what we can write it, new volume is equal to 1 plus alpha minus 2 beta, and here it will be T plus T plus T, that is equal to 3T. So, our new volume is 1 plus alpha minus 2 beta into 3T. Now, this is the new volume, and what we knew that the original volume is 1 in 1 unit. So, if we want to calculate the change in volume, then it will be equal to the new volume minus the original volume. New volume is 1 plus alpha minus 2 beta into 3T, and original volume is 1. So, we have to subtract that. So, if we find out what is the change in the volume, it is alpha minus 2 beta into 3T. We will write this as equation number 4 and equation number 5. We are able to, because we have to derive the bulk relation, in the relation we have one term bulk modulus. So, first what we are trying to calculate, what is the bulk modulus of the cube when the force tension is applied. Now, if we consider that instead of tension T, the pressure is uniformly applied, pressure P is uniformly applied to the cube from all the directions, then we can replace this T term by P, and when you apply uniformly the pressure, what you will get? Instead of elongation in the cube, you will have compression. So, now what we can write, the change in volume, it will be equal to alpha minus 2 beta into P. Alpha minus 2 beta into P, 3P. As it is 3T, here we will have 3P. Now, we want to calculate the volumetric strain. So, what will be the volumetric or we call it as bulk strain? It will be change in the volume by the original volume. And what we know that original volume of the cube is 1. So, if you divide by 1, you will get the same term. So, we will get alpha minus 2 beta into 3P. Again repeating, change in the volume is alpha minus 2 beta into 3P. So, if we want to calculate the bulk strain, which we call it as volumetric strain as well, it will be change in the volume divided by the original volume. And as the original volume of the cube is 1, if you divide this volume change in the volume by 1, you will get the term alpha minus 2 beta into 3P itself. So, our volumetric strain or the bulk strain, it is alpha minus 2 beta into 3 into 3P. Hence, the bulk modulus which we define it as stress by strain, means volumetric stress, you can call it as bulk stress as well, divided by the volumetric strain. So, what is the volumetric stress? It is P, and the volumetric strain what we have calculated, it is alpha minus 2 beta into 3P. So, now P is in the numerator and the denominator as well, it will be cancelled out, and what we represent bulk modulus as K, K will be equal to 1 divided by alpha minus 2 beta into 3 to 3. So, K is equal to, we have derived the relation for the bulk modulus. Write it as equation number 8. Repeating, first we have calculated the change in volume when the instead of tension the pressure is applied. Then we have calculated the volumetric strain. Then we have calculated the bulk modulus, which is stress by strain, and value after substituting we get the bulk modulus is equal to 1 divided by alpha minus 2 beta into 3. Now, as usual we have, when we found the relation between Young's modulus, rigidity modulus and Poisson ratio, we had divided the numerator and denominator by alpha, means the longitudinal strain coefficient, and will similarly we will do for the equation 8 as well. So, equation 8 will numerator and denominator will divide by alpha. So, we get K is equal to 1 by alpha, and alpha divided by alpha, it will be 1 minus 2 beta divided by alpha, and 3 what it is multiplied, will write it in the front. So, now what we get, the bulk modulus, and what we know 1 by alpha, alpha is what? The longitudinal strain coefficient, which is longitudinal strain per unit stress, and if you take the reciprocal of that, it will define Young's modulus, which is longitudinal stress by strain. So, this 1 by alpha is can be written as Y, which is Young's modulus, and it is 3 1 minus 2, and beta by alpha we know it is Poisson ratio. So, it is 2 sigma, and we will rearrange the equation. We will get Y is equal to 3k 1 minus 2 sigma. So, finally, we arrive to our question, which is what we are trying to do. We are trying to establish a relation between Young's modulus, bulk modulus and the Poisson ratio. So, what we get, Young's modulus is equal to 3 multiplied by bulk modulus into 1 minus 2 multiplied by the Poisson ratio. So, equation 9 gives the relation between Y, K and sigma. So, now we will derive the relation between Young's modulus Y, bulk modulus K and the rigidity modulus, which we denoted by eta. So, as already I have explained the relation between the Young's modulus, bulk modulus and Poisson ratio, which is Y is equal to 3k 1 minus 2 sigma, and the other relation we have derived the relation between Young's modulus, rigidity modulus and the Poisson ratio, which is Y is equal to 2 eta 1 plus sigma. So, this 2 equation itself will consider to derive the relation between Y, K and eta. So, we will take the first equation, we will further simplify it. What we get, equation 1, what we can write, Y divided by 3k. This 3k, take it to the denominator of the left hand side. This will be equal to 1 minus 2 sigma. What we are trying to get the expression for sigma. For both the equation, we will solve it to get the expression for sigma, the Poisson ratio. So, what we get, 2 sigma is equal to 1 minus Y by 3k, or sigma will be equal to 1 by 2 minus Y by 6k. What we have done, Y, we have taken 3k to the denominator, we get Y by 3k is equal to 1 minus 2 sigma. So, 2 sigma will be minus 2 sigma will be equal to Y by 3k minus 1. So, to remove the negative sign here, what we will get, 2 sigma will be equal to 1 minus Y by 3k, and this again 2 if you divide it, sigma will be equal to 1 by 2 minus Y by 6k. Let us write it as equation number 3. Next, we will take equation number 2 and again solve for the sigma. So, from equation 2, what we have, Y by 2 eta is equal to 1 plus sigma. Y divide by 2 eta, take it to the denominator, that is equal to 1 plus sigma, or sigma will be equal to Y by 2 eta minus 1. Now, as equation 3 and 4, it is both the expression for sigma, the Poisson ratio, because we need relation between Y, K and sigma. So, what we have to do? We have to remove yk and eta. So, we have to remove the term sigma. So, what we did? We have simplified the equation to get the sigma expression for sigma. So, we have resolved it. Now, as both is the term expression for sigma, so if left hand side is equal, the right hand side must also be equal. So, what we get from equation 3 and 4, one by 2 minus y by 6k. It will be equal to y by 2 eta minus 1. Now, if further simplify, we get y by 2 eta plus y by 6k. It will be, we have taken y by 6k to the either side and take 1 in the either side, 1 by 2 plus 1. So, now y is common, it will be 1 by 2 eta plus 1 by 6k and half plus 1 will be equal to 3 by 2, or we will take the y term in either side, 1 by 2 eta plus 1 by 6k, it will be equal to 3 by 2y. Now, we will take LCM of this, we will get 6 eta k. So, we will have 3k plus eta. 3k plus eta, that will be equal to 3 by 2y. Or further, if we simplify it, we will just reverse the equation. 2y by 3 will be equal to 6 eta k divided by 3k plus eta. So, finally, when we solve it, when we solve this equation, 2 will go to the denominator and 3 will come to the numerator. We will get y is equal to 9 eta k divided by 3k plus eta. So, equation 5. Equation 5, what it is? Y is equal to 9 eta k, 3k plus eta is, there gives the relation between Young's modulus, rigidity modulus and the bulk modulus. So, if you divide this equation by this number by 2 eta, you will get 3k into 1. Now, if you divide it by 6k, you will get eta. So, you have 3k plus eta divided by 6 eta k, and this is 3 by 2y. Now, we have interchanged the equation as well as we have taken the reciprocal of this equation. So, if you take reciprocal of this term, you will get 2y by 3, and if you take reciprocal of this term, you have 6 eta k by 3k plus eta. Now, further you multiply this by 3 and divide this by 2. So, if you again if you say, if you cancel it 2 3, 2 in, it will be cancelled by 3 and 3 into 3 is 9. So, what you will get? Y is equal to 9 eta k divided by 3k plus eta, which is the relation between, equation 5 is the relation between y, eta and k, that is Young's modulus, rigidity modulus and the bulk modulus. So, next we will establish what is the limiting value of the Poisson ratio. So, similar equation what we have derived earlier and in the previous explanation also, while deriving Young's modulus, bulk rigidity modulus and the bulk modulus relation. We took these two equations which we have derived earlier as well. So, what we have? Young's modulus This is equal to 3k 1 minus 2 sigma, and again Young's modulus is equal to 2 eta 1 plus sigma. K is bulk modulus, sigma is Poisson ratio, eta is rigidity modulus, sigma again the Poisson ratio. Now, to find out the limiting value, what we see here, both the expression is for Young's modulus. So, if left side of equation is equal, right must be also equal. So, we will equate it, we get 3k 1 minus 2 sigma will be equal to 2 eta 1 plus sigma. Now, from these equations, what we can see that if 1 minus 2 sigma is a positive number, is positive, then what it will be? 1 minus 2 sigma must be greater than 0. So, from this what we get, sigma is equal to half and this is equal to 0.5. Now, if we take 1 plus sigma, so if this 1 plus sigma, what we see that if you find it out, if it has to be positive, then this must also be greater than 0, and this says that sigma is equal to minus 1. So, from these two relations, what we see that sigma lies between 0.5 and minus 1 as per the relation 3. Sigma lies between 0.5 and minus 1. But if you consider the negative value of the Poisson ratio, it means that in the longitudinal strain, the lateral strain also produces expansion, which is not practically possible. So, what we consider for the practical value, sigma value must be between 0 and 0.5.